All right, everyone, welcome to the next project. In this one, we're going to be building Robo HR, which is a personal HR assistant that can summarize some resumes for us. Okay, in this one, we'll be using document loaders, embeddings, the summarization chain. We'll be using Pinecone once again, and we have a bunch of resumes here in the data folder of the project. Basically, just a bunch of fake software engineering resumes. And so we are going to load those into a Pinecone database. You can create a new one or just use the same one since the data is going to be pretty different. And so even if you don't make a new Pinecone instance, you should be still getting relevant results. However, feel free to delete the index from some of the previous videos and create a new one if you're seeing some weird issues. And I'll just show a demo of how this works. We can just say who has experience with Python, and it'll show us who. This is that source document. I'll try another one. Who has worked at Meta? And it'll actually tell us that Anna Smith, should be Joanna Smith, has worked at Meta as a backend developer from 2017 to 2019. And so it's able to give us the source of the information as well as kind of give us a little summary about Meta, even though we didn't ask that. Okay, so it's kind of able to infer our context as well. Okay, and just to briefly go over what we'll be doing, first, we're going to upload the resumes to a Pinecone vector store once again. And you can use the same one from the previous projects. And if you don't want to use that, you can simply delete it and create a new one. Just make sure to use that same max dimensions of 1536, which is the dimensions that's needed for an OpenAI embedding. And then we are going to use index related chains in this one, and I will go over this theory a little bit later. So we can take a sneak peek at the code as well. So basically what we're going to do is make some API calls once again to our backend. In the first part of this video, we are going to make queries using the metadata property of our vector store using the vector-db QA chain. That's going to return us some of the most relevant results. The second way that we're going to do it is use a vector store toolkit to create a vector store agent. And I found that these are also able to give some pretty good responses from the vector store. So in this project, we're going to get two different ways of interacting with the Pinecone vector store. One is by using the metadata and one is by using a agent. All right, let's jump into the front end code on the next video. I'll see you there. All right, so in this video, I'll briefly go over all the files that you need for this section of the course. So for the front end, we will be using resume reader, which is in the app/resume reader directory. And in here, we basically have the same UI from before, got the imports and the use client. And then here, we've just set some initial values for the prompt as well as the messages, just so our UI will be styled. As you can see here, we have that first message as well as that first prompt. And going back to the code, we can see what happens whenever we handle submit, which is when we click enter. And so we're going to set some new message to the messages array. Okay, so this is what happens when we call the resume upload. Okay, so this is going to be this upload resumes button. And when we click it, we're going to go into this resume upload file in the pages/API. And then we are going to grab all the summaries and just parse them into an array. And then our chatbot is going to summarize each of those messages. I'll explain this again later when we have a response from the backend. But all you need to know is that the handle submit upload is linked to that button, which is right here, that handle submit upload. And it's passed there as a property. So the next thing that we will look at is what happens when we press enter. So this is the handle submit for the prompt. So after we submit a prompt, we are going to put this at the bottom here. That doesn't belong there. All right. So it should be fixed for you when you see the code. So first we're going to set the loading message as well as set the user message. In this one, we're only sending the prompt in the body. And then when we get a response back, we're going to remove that loading message right here. And then we're going to push the new response from the backend into the messages array. Okay. So in the next couple of videos, we will start to fill in the resume upload, the vector store, and the metadata queries. We will start figuring out how we can upload an entire directory into our vector database. I'll see you there. Okay, welcome to the resume upload section, where we're basically going to take all of those resumes that you saw earlier in this data folder. And I've just got a folder here with all the resumes. And basically what we have to do is load that entire directory into the vector database. Okay, so we are using Pinecone once again. So feel free to just use the same one as last time. Make sure your API key is in the .env file and that your next.config.js is set up correctly. Should look something like this. Okay, we will only need the OpenAI keys and the Pinecone keys for this one, but you can keep everything the same. All right, and so let's start to write some code here. So the first thing that we need to do is load the directory. And we'll do that using the directory loader from LangChain. Okay, and this allows us to load an entire directory by giving it the directory path. And then basically the options, which is the second part of the new directory loader. So first we'll create that new directory loader. The first part that we need is the path. So I'll go over here, copy that path, paste it right here. Okay. And then we'll go create a options object. So all of these are just .pdf. And the second thing we need to pass is the loaders mapping function. And that's just going to be an arrow function that takes the path and makes a new PDF loader. So we're using the entire directory, and then for every single PDF in there, we're using the PDF loader. All right, and this once again takes a path, which is right here, and we give it the /PDF string. Okay, so after we load the entire directory, we will need to actually load it using loader.load. And let's just see what that looks like. Okay, loaded docs.length. Since this gives us back an array, we can check the length of it with that. And we'll start our server up like here. And then we'll go to the RoboHR page. Resume reader is not defined. Going on. Oh, I just forgot to name this as page.jsx, but it should be correct in your file. Go back and it looks like it's working properly now. So let's just click the upload resumes button. This is not really going to do anything yet, but let's go back to our back end. And it says that we loaded 3 documents. Perfect. We've got 3 documents in here and they're all loaded into our docs variable. All right. And then here we've got the document split up. And so this is a little bit smaller. And it also gives us the metadata for that document. As you can see, it's the metadata has a source, a PDF, and a location. Okay. And one of the tricks with vector databases is to actually give a more relevant metadata object so that we can query it later. And so you can probably guess that this stuff right here is not that useful to us. We don't really care about what version Adobe Acrobat is. So let's create another function now to reduce the metadata and make it more searchable. Okay, so we're going to create a new reduce docs variable that takes split docs, and we're going to use the .map array function, and basically this does a operation on every single document in the array. And what we're going to do with that is return a new array, and not a new array, but that new doc. Instead of a doc, we're going to have that same doc, but instead of the previous metadata, which was all of this stuff, we want to reduce it down to just the first name, which is the first name, the last name, which is the last name. And so let's define that up here. Okay, so the first name is just going to be the file name. As you can see up here, we got resume Aubrey Graham, and that's just going to be the metadata dot source. So metadata dot source, and we'll use the split method, and a split method is going to do this. I'll just show you first. If we split according to the slash, so the return from a split is going to be something like this, where it's like users Sean Esquivel dot, and then the last spot in the array is going to be resume Aubrey Graham.pdf. Okay, and so we just want this last piece of the array, so we'll just pop that as well to get the file name. And then what we're going to do here is take that file name, which is resume Aubrey Graham, and we'll do another split on that with the underscore character. So that is going to give us a array once again, and it's going to give us resume Aubrey, and it's going to give us like a Graham.pdf. Right? So as you can see here, the first one's not useful. The second one is useful. So we'll destructure that into first name. And then the third one is going to be that last name. Okay. And then just for that last name, we will take that first name, put it there since it's correct. We'll take that last name, and we need to remove the .pdf, so we'll just use the .slice method for strings, and we want the 0th number to the -4th number. So we want to not have 1, 2, 3, 4 characters. So it's just going to take the last name there. Okay, give that a save. I will comment these ones out. Comment this out. Okay, so let's console.log what our reduced docs, let's say 4 looks like. Okay, so if we go to our application, click uploading resumes. Is it working? Let's give it a refresh. Give this another save. And let's try one more time. Cannot read properties of source. Docs.metadata. Oh, it should be a doc here since we want the doc element of the array. Okay, let's try one more time. So just to explain that again, we're using the dot map to go over each element in the array. So the doc has to match the position element right here. Okay, so we're not going over these docs. We're going over this doc, which is just an element in split docs. Okay, hopefully I didn't confuse you. Give it another save, give this another refresh, and we will upload resumes again. Okay, now you can see that our metadata for the 4th document is now accurate. So we've got the metadata for Joanna Smith is right there. Okay, and we'll just say that this is a doc type of PDF just to make it, well, we'll call it a resume. We'll call it a resume. Okay, so we'll go back one more time, upload resumes. Is it working? Give it a save, refresh, upload one more time. Okay, so now we have all of this metadata about our document so that for each of those split chunks that we made earlier, it's still going to understand where that came from and who this is relevant to. Okay, so I think that was a lot for one video. So just to recap what we did, we used a directory loader to load all of the PDFs into one variable using the PDF loader for each .pdf file extension. Then we split up the documents into a chunk size of 200 and made them a little bit smaller. Okay, and then in this last function that we made, we just reduced the metadata down. So we had a lot of junk in the metadata of the documents, and so this is a much smaller version, which is a lot easier for us to query. All right, in the next video, we will use the summarization chain to make some summaries about these documents. And so I will see you guys in the next video. In the last video, we created these reduced docs, which have a very nice metadata property that can be searched. So in this video, we're going to create a load summarization chain, which is going to allow us to summarize these long documents. Okay, so first of all, we're just going to set a summaries object to a empty array. And basically, we're going to use the summarize all chain, which uses the load summarization chain, which we already imported up here, which is just one of the types of chains that LangChain offers. And we're going to pass in a model. I don't think we've defined that yet. Const model equals OpenAI, and we'll give it a temperature of 0. Okay. So now that we've done that, we need to pass another argument in here, and that's the type of summarization chain that we're going to use. So let's have a look at that. So as you can see here from the type definition, you can pass some additional summarization chain parameters, and the default method here says stuff, and you could also pass map reduce, or you could also pass refine. Okay, so what does that mean? What does stuff, map, reduce, and refine? Well, basically, the summarization chains allow us to summarize long documents. Okay, so you might have heard about the 32K context limit with ChatGPT. For example, if you load a file that's way too big into, or way too big of a message into ChatGPT, it's not going to let you, it's going to tell you to give a smaller response. And that's just because there's context limits. Okay, so I'll just briefly go over how to use a summarization chain before we write the code out. And so basically there's three types of summarization chains, okay? You can use the stuffing method, the map reduce method, or the refine method. And there's this really nice diagram here from an article where the stuffing method basically takes all the documents and creates one really big prompt and includes that in the prompt to the LLM, okay? And so the con with that, well, the pro with that is that it's very simple, right? You just put all your documents in with your prompt. The con with that is that if your documents are too long, you might exceed the context limit, okay? The next one is the map reduce, and this basically takes an initial prompt on each chunk. And so if we go up here, if we have an example of these three documents, just summarizing some movies, you can see that they have a little bit of length to them. And so during the map phase, I'll scroll down to this diagram here. During this map phase, we basically summarize each document individually. So from a big piece of text, you can get a smaller piece of text. And the goal is to still be able to understand what that document was about, but basically having a little bit of a smaller message to describe that. So you can imagine that there is a little bit of context loss here, but the point here is that all of these methods have their own trade-offs, and it's basically us having to make the right decision for which one is the best to use for our use case. Okay, so after it creates a summary of each of those documents, it's going to take all of that and create a final summary, and we pass that to the LLM. Okay, so it combines all of that, all of those documents, makes one sentence, and passes that to the LLM. Okay, the pros about that is that there's more context per document, but the con is that we have more calls to the LLM. Okay, and so the last method is the refine method. And this is basically a way that we can have local memory. Okay, so the LLM summarizes the documents one by one, and it basically creates a chain of summaries and repeats that until all the documents have been processed. Okay, and you can read a lot more about this in detail in this article, but for our purposes, we'll keep it pretty simple, and we're just going to use the map reduce method here, which allows us to make a bunch of mini summaries about our documents. Okay, so this is going to be useful for us when it comes to resumes, because we can use the summarize response, and we'll say summarize all chain dot call input documents docs. Okay, so we're just gonna use the raw document. So this one where there was 3 total documents, and I just want to get a quick summary about each of them. Okay, so to do that, we will call the summarize all chain with the input documents of docs. So this is using the raw documents. And then we're just gonna, for each of those summaries, All right, and then we're just gonna push that final summarize res.text, and let's see what we get back. Let's console log summaries, and we'll see how this works. Okay, let's go back to the local host, click upload resumes, open AI, forgot to type new here, give it another save, give it another refresh, and we'll click upload again. Summary is undefined. The call should be awaited. Yeah, okay. Let's try one more time. Refresh, upload. Go back to the code. And we'll see here that it gave us a summary of each of the resumes. Nice. So this is just a quick way for us to get a summary of all of the documents. And so this summarize all chain, we can make, basically we can ask this prompts. So, okay, so the first response is just going to be a summary of one of the documents. And then we are gonna upload the split documents. What is it called? The reduced docs. Yeah, reduced docs. And to do that, once again, we're just using the client for Pinecone. And we'll await the client.init, and we'll pass it our API key for Pinecone, and the environment is gonna be this same part from above for the Pinecone environment. Okay, and then the Pinecone index equals client.index, and we'll pass in the name of our Pinecone index, Pinecone index, and then we will await Pinecone store. We initialize that. We did up here. Okay, good. Got Pinecone store, and then what we're gonna do is from documents, the reduced documents, we're going to use the open AI embeddings as the engine to make the embeddings work. And then we'll pass in the name of our Pinecone index. And then finally, we'll say uploaded to Pinecone. Give it a save. Okay, and we want to make a summary of each candidate. And we'll do that just by using the exact same method up here. And we'll do that by using the for of. And the for of in JavaScript, just a reminder, it lets us do something on each element of an array. Okay, so if you have an array, you can do something on every single element of that array. In this case, we have the docs array, and for every single doc in the docs array, we are going to create a mini chain to summarize one document, and we're going to pass in the OpenAI model, and we'll tell it the type, which is just the map reduce. Okay, and then we will get a response from that using the summarize one res, and we'll just await summarize one chain dot call and we'll pass the input documents, which is supposed to be a vector like it was up there. So we just have to pass that doc, which is an element of the vector, and we just have to pass it back in as a vector. Okay, so we'll just console log each of those summaries. Summarize one response, and then we will push it to our summaries array up here, just using the push, and we'll push that response. And we'll do it like this. We'll say summary, and we'll say summarize one res. Okay, getting some errors, forgetting something here. Expression expected. Oh, okay. Just take that out there for now. Give it a save. And before we do this pinecone stuff, let's just take a look at what our summaries looks like. First off, we'll just make sure that we actually return something to the front end. So we'll return a status of 200, and we'll return a output of the summaries. But remember, the summaries was an array of objects, so we're going to need to do something else for that. So currently the summaries is a bunch of summary objects like this, blah blah blah, and so we need to flatten that into just a string so we can send it to the front end. So we'll call it a summary string, and we'll use the json.stringify, which converts a JavaScript object into a string, right? So we'll pass the JSON, we'll pass null, and we'll put 2 white spaces. And so now we can pass the summary string back there. Okay. And then in the front end for the resume upload handler, we're just going to take that response and we're going to parse it back into an object. So we turned it into a string in the back end, and then here we turned it back into an object, and then we're just going to put each of those objects into a new messages array, and then we're just going to push all of those into our messages state by destructuring the previous messages and adding those new messages from the backend. Okay, so let's just do that first to make sure we can get some summaries. Another look, give it a refresh, do some saves, and try uploading again. Okay, so it's creating those chunks. And it's clearly using a bigger chunk size, so we can even increase this chunk size over here, but I'll just keep it as is. So there you go. We're starting to get the summaries of each of the PDFs, and it's telling us all about their education, their work experience, and their skills, which is awesome. That's exactly what we want to see. And yeah, that's pretty good. As you can see here, we've got a little typo on the name, and that might be just because of that PDF formatting that we had for this. We open this in the Finder window. So basically, because of our PDF format style, it might not be always seeing these sentences the proper way. So that's just kind of a thing that is an issue when you're working with PDF documents, especially with like Word documents that have different types of formatting applied. You might not always see the text as you expected. Okay, but overall, it's looking pretty good and good enough for the scope of this project. And let's go back to the front end. And it looks like indeed our summaries did get pushed into the messages array. And so those are properly getting added to the front end. So this is that big summary of all of the documents. And then we have 3 mini summaries for each of the resumes. All right, so in this last step here, we're just gonna make sure that we actually upload those documents to Pinecone. So remember, we wanna upload the reduced documents, and we'll just say that we upload it to Pinecone. Okay, let's give it a refresh. Let's check our Pinecone console. So right now we have 1147 vectors. And we will upload the resumes. And we will watch to see if this is going to change from 1147. So once again, it's just running through all of this code, creating those chunks, creating the summaries, which takes a little while. And if you're prototyping this, feel free to like comment out these await statements since they are the ones causing us to have a little bit of delay. Okay, looks like our summaries are done. And it says we uploaded to Pinecone, so let's see if that actually worked. And it looks like it did. All right, so I believe we had 8 or something documents. So 1147 plus 8 is that correct amount of vectors here. Awesome. So now our vector store has all of our resumes uploaded as embeddings. And so in the next video, we will start to create our resume query metadata route, which is going to let us use the vector DB QA chain to ask questions to our documents. Hello everyone, welcome back. So in this video, we are going to chat about an alternative to Pinecone. And as you can see here, the waitlist for Pinecone is extremely high due to it being one of the most popular services for building vector databases. So one of my students recently let me know that it took them about a week to get off the waitlist, and so I immediately jumped onto learning another vector database. That is going to be Supabase, but I also wanted to just mention some of the other ones that are out there. So basically, you can use any of the vector stores here on LangChain. You've got Chroma, HNSWLib, Pinecone, Supabase, and we've been using Pinecone for everything. However, with the waitlist, it might not be available for you to use it, right? So there's some other ones such as Chroma, Weaviate, but I don't like those solutions, at least for these tutorials, because you have to run it on a Docker on your computer, and that can be a little bit more complicated to set up, which I don't like. And so after doing a bunch of research on all these available options, I settled on Supabase, thanks to some recommendations from some students in the course. And I went through it, tested it out, and it's super simple to set up. Okay, so first thing that you're gonna do is go to the Notion course docs. Okay, I'll link it to this video. But basically, I've put in all the theory for this section. So make sure to check that out if you haven't already by going to the Notion, scrolling down, and then checking out the Supabase page. Okay. So in this, I've put in some theory about what Supabase is, like why we would use it, why we need to use Supabase, as well as what it is. So I'm not going to go into too much detail on that. You can read up more on the theory of Supabase in here. The quick 5-second summary is that it's an open source Firebase alternative. And so we're going to be using one of the new features of Supabase, which is called PG Vector. And this basically allows us to get a OpenAI embeddings with like Postgres, which is one of the most popular SQL databases in the world. And they've launched some support so that you can use OpenAI embeddings along with the Postgres database. So you kind of get the best of both worlds here. And definitely read more about it in this blog post. But we've basically gone through most of the theory here in the other videos, so I won't go through like what an embedding is. We've already gone through that multiple times in the other projects. So you can read more about that here if you'd like. We're just going to quickly set it up and get you up and running. Okay, so we're going to modify the AiHR product. And to do that, first of all, we're going to go to the Supabase docs and copy the npm install command. Go back to our project and paste that in. I've already done this, but you should see it show up in your package.json file, which is good. Next thing that we need to do is get some API keys. Okay, so we're going to go back to, let's go check out our steps here, which I've laid out right here. So next we're going to go make a Supabase account. And we'll do that by going to supabase.com. We'll start our project, and you'll probably be prompted to create your account, but I've already done that. Then you can create a new project, okay, and just accept the default settings and give it a name. I've already reached my max quota here, but once you've created a project, you should be able to access it here, okay? So after I go to my project, you'll be sent to this dashboard. So next thing that we need to do is go to our SQL editor and hit new query. And then we're going to go back to LangChain and do this second step, which is create a table and search function in your database. Okay, this is basically doing 3 things, and it's a bunch of SQL, which we're not going to go through, but if you want me to break this down further, I will, but I'm just going to give you the 5-second summary. First thing, we're allowing our table to use the vector extension so that we can use the OpenAI embeddings. Second thing that we're doing is creating a table, and the table is going to be called documents. It has a primary key, which is just the ID, content, metadata, and the embeddings column. So it's got 4 columns in total, and you'll see that when we run the code. And then it also has this function that allows us to search for documents, okay? I'm not gonna go through it super in detail here, but feel free to message me on Discord, or maybe I'll add something into the Notion course documents on how that works, but I just wanted to quickly make this video on how to set it up for you. Okay, so we'll take this code, copy it, go back to our SQL editor in Supabase, and we'll paste that in, and you're gonna hit run. Okay, so you might have to hit Command A or Control A and hit run, but when you click run, you're gonna get a success message here. I've already ran the table, so I'm not gonna click it again, but after you click run, you should see a success message, but let me know if you don't see that, okay, and we can troubleshoot. Okay, so after you've run that SQL query, you should now have a table called documents with 4 columns. So let's go back to our table editor and check that out, and it looks like it worked. We've got our documents table, and mine's already filled out, but I'll just refresh it for you guys to see by deleting all the rows. So yours is going to look more like this, where you have some content, metadata, and an embedding column, okay? Next thing that we need to do is grab some API keys. To do that, we're going to go to the project settings, hit API, and grab this URL, okay? So we're going to go back to our .env, and I've already filled mine out, but I'll just do it again for you. So you're going to make a Supabase private key and a Supabase URL. And I think I just copied the URL. Yeah. So I'll paste that in here. And then I also made a API key, and that goes right here in your private API key. So the solution for this section is gonna be in the solutions folder under resume upload Supabase solution. But the first thing that we need to do is grab some exports, or some imports, sorry. So we're gonna go to our resume upload, and instead of using Pinecone store, Pinecone client, we're gonna be using the Supabase vector store and the create client from Supabase. Okay, so remember we're in our resume upload, which is for the AiHR project, or the resume reader project. And in this one, we loaded some resumes from a directory, split up some chunks, reduced the metadata size down, and then we used the summary chain to make some summaries about each of the resumes. And then here is the vector store part that we're swapping out, where we connect to Pinecone and we upload the docs to Pinecone. Okay, so I'm just going to show you how to swap that out. So I'll take all that out. So instead of, maybe I'll keep it, I'll comment it out. And so we'll call this the Pinecone version. And then we'll do another one here called the Supabase version. Okay, so I'll just go to my solution file and I'll grab some code. It's not a lot of code right here. So instead of connecting to client, initializing with our API keys for Pinecone, and then uploading to Pinecone, we're going to do the exact same thing, but with Supabase. So first we check our API keys by checking our process.env for Supabase URLs. And let's go back to our next.config.js file. And what I've done here is I've added 2 more rows here for my Supabase URL and my Supabase private key so that they can be available to us in the backend, just like we've done with all the other API keys. And next thing that we do is connect to the Supabase client. So if I hover over this, you can see that we are using the Supabase client, and that's from the create client that we imported up top. And then exactly the same as before, we're going to await vector store from documents and pass in the documents and the OpenAI embeddings. So you can see that they're almost exactly the same. And this is one of my favorite features of LangChain, which is that everything's super modular, which makes it really easy to swap out services when something like this happens, like a free trial runs out. Okay, so now that we've set up our API keys and we've written some code to upload to our Supabase vector store, we're going to pass in the reduced documents, which is, remember, just the resumes as some cleaned up metadata and split into chunks. We're going to embed that using OpenAI embeddings. Then we're going to pass in some Supabase arguments. So you can see first argument docs, second argument embeddings, third argument dbconfig. And here, the dbconfig, you need to pass in the client, which is this guy, the table name, which is documents, as you saw before. Our table name was documents. And the third thing is the query name, which you can see from the SQL earlier, that this was the function that helps us search for documents. Okay, so it looks like everything's matching up here. And we can give it a save. So now we've successfully replaced the Pinecone with the Supabase. So let's npm run dev to check out if everything's working. We can ignore this. And let's check it out. So we'll go to localhost 3000. we'll go to this link for resume AiHR. Okay, and just a refresher on the front end for resume reader. The resume reader is reading, or first it's going to this resume upload link. Okay, you don't need to do this, look, but yours should still look like this, where it's going to API/resume upload. So that's the one we've been modifying, resume upload. Okay, so it's going to enter this code, and now it's going to use this Supabase. Okay, so let's give it another save, and we'll go back to our front end, and we'll see if we can upload the resumes again. Okay, so you can see it's created the chunks. So it's done the first part of the code, which is loading all the resumes, splitting them up, and now it's probably splitting the documents. And you can see here it's starting the summary chain, so it's starting to summarize each of the resumes. And then now it's probably checking for our API keys, and now it's going to upload to our vector store. Okay, so you can see it's done the summary for each of the resumes just like before. And now we should see, yeah, there's a line right here. So this is after we do the await Supabase vector store, we get this warning message. So this is just if you're using authorization, for example, if users are logging into your web application. But for the scope of this course, we're not doing that, so don't worry about this. If you want to make this go away, just follow this warning message, and you can disable the warning. Okay, so it looks like everything worked properly, and we were able to send that output summary string back to the front end. Let's check it out. So it looks like everything's still working properly, where the resumes from before are getting summarized and sent back to the front end. So now let's check if the Supabase vector store got updated properly. Remember, it was empty earlier. And there we go. We've successfully uploaded some embeddings. So this time we've got, looks like 3 chunks for the first resume. You can see first name and last name right here for Aubrey. And then you've got another 2 chunks for Joanna and 3 chunks for Kaido. Okay, so the nice thing about the Supabase dashboard is that it's super readable, and you can kind of delete resumes as you please. Let's say you don't want like this one anymore. You can take it out and basically modify your vector store. And that's something that we weren't able to easily do with the Pinecone dashboard. I'll just show you that really quickly for a comparison, which was that the Pinecone dashboard did not show us all the different vectors that were in our vector store, right? So with Pinecone, this was what our dashboard looked like for my vector store, and all we saw was the total number of vectors. We could add it with a namespace, but we didn't do that for the purposes of our course. Okay, and then getting back to this, the next thing that we need to do to modify our code again is we're going to go back to the code. And so now that we've successfully migrated resume upload to use the Supabase solution, we're going to now modify the query metadata to do the same thing. And so you can see I've already done it in this code, where I've just done this by importing the Supabase vector store and client instead of using Pinecone. And you can see all I did here was I commented out the Pinecone client index and vector store, and same thing, I replaced it with the Supabase client and vector store. Okay, so this is the only code that's different, so let's compare it. You can see that I created a vector store, I awaited Supabase vector store instead of Pinecone vector store. I used the exact same from existing index. I passed in the same first argument, and then the second argument was slightly different since the Supabase vector store needs to know the table name as well as the query name that you're using to search functions, okay? So you can see it's super similar, and we'll comment this code out so that it'll work. So the only difference that we made to this code is we connected with our Supabase vector store. Okay, the rest of this code stayed the same, where we create a vector DB QA chain, and now it's using the Supabase vector store, and then we're still doing the prompt template and the chain call as we were before. Okay, so let's give that a save, and remember, if you want to see the solution, you can always go to resume upload, resume query, metadata, Supabase solution. Okay, it should be this one. This was the solution file. If you're interested, it'll be in the solutions folder. Okay, so next thing that we do after we save is test it out. So you can see this is the vector store that we're going to query from now. Let's just ask it, who is Kaido? So it looks like we've got summary of Kaido, and it looks like that's pretty accurate to what was on his resume. And you can see it also pulls out the source document for this, and this is basically one section of Kaido's resume. Let's ask it another thing just to make sure it's still working properly. Let's say who has worked at Meta. And you can see it's got Joan Smith. Kind of got confused about Joanna and Joan, and that's just due to the way that our resume was parsed. But it looks like everything's working properly now. Okay, so just another quick overview. All we did was swap out about 10 lines of code from Pinecone and swapped it out with about 10 lines of Supabase code in the resume upload. We did the same thing in our resume query metadata. We swapped out the Pinecone code and we put in some Supabase code. Okay, so theoretically, we're doing almost exactly the same thing. Okay, and you can adapt this to the rest of the projects as well. So for example, for PDF upload, you would do the same thing here, where instead of uploading to Pinecone, just take that exact same code from here and replace that like this. You can see that it's almost exactly the same in the PDF upload code. And in the PDF query code, you do something, again, very similar, where instead of this Pinecone code right here, you would take the code from resume query metadata, Supabase solution, and you can just take this connect to Supabase code and replace it like that. PDF query, and just like that. Okay, so you can do that for the rest of the projects that are using Pinecone as well. I'll upload some code in the Notion kind of database so that you can have all the code available to you to swap out as needed. But feel free to message me on the course Discord if you have any questions like this. I'll be happy to help clear it up for you. Okay, so if you haven't already, make sure to join the LangChain JavaScript and post your questions and troubleshooting if you're having any issues. Okay, so that's it for this video. Hopefully you enjoyed the extra lesson. And of course, if you want to test out any of the other vector stores, feel free to let me know in the request new video section, and I'll be free to cover some additional resources as people request them. All right, and just one last thing that I wanted to mention about the course is that hopefully you've been enjoying it so far and enjoying the continuous updates I've been making to deployment, as well as this new section on using Supabase. And if you've been enjoying the course, I'd really appreciate it if you could take a couple moments here to leave a course rating. It really helps me to not only improve the course for you, but for future students who will take the course. And it also helps me to get the course in front of more students I just really would appreciate it if you'd take some time. And of course, continue to message me on Discord on troubleshooting if you're having any issues. Let me know if you're stuck. Let me know if something's not working properly. I'm happy to help out no matter how big or small the issue is. And really, I just want to make this course one of the best courses on LangChain and JavaScript on Udemy. So once again, thank you for your feedback. Thank you for being a part of the course, and let's continue learning. See you in the next one. Alright, so in the last video, we uploaded all of those resumes as embeddings into our vector store right here. So we should be able to start populating this API route for the metadata. And so I've already imported all the libraries that we're going to need. As usual, Pinecone, OpenAI embeddings. And in this one, we are going to be using the vector DB QA chain. And this is a chain that allows us to really easily ask question and answers to the vector database. Okay, so first off, let's do the usual, and we're going to grab the prompt from the request body like that. We go to the handle submit. It's fetching this endpoint, and we're passing that prompt in. And let's just make sure we have that endpoint set to resume query metadata. So make sure those two match and save your front end. Go back to the back end, and we will take that prompt and do something with it. But first we need to load the vector database, and we'll just copy in that code from here. This stays the same, so that's going to let us use the Pinecone store. So next thing we need to do is create a vector store, and the vector store is going to be initialized using the Pinecone store, and we're going to use the from existing index method, pass the first argument as the OpenAI embeddings, and we'll pass our index name, Pinecone index, like that. All right. So the next thing that we need to do is create the vector DB QA chain. And this allows us to return the top results for a given query. Okay, so first thing that we need to do, as always, is use that new OpenAI instance for the model, and then we're just going to make a chain for vector DBQA chain, and we'll say from LLM, and we'll pass in the model. Second input is the vector store, and the third input is some options you can see here. And so let's take a look at that. So the vector DBQA chain, one of the options that we want to pass is the K, and another one that we want to pass is this return source documents. Okay, so the K just tells us how many of the most relevant results we want to return. So if you set that to 1, it's just going to return the first document or the first array or embedding that is closest to your query. But let's just set it to 2 so we can get 2 documents back. And then the second thing that we wanted to define was this return source documents, which is a Boolean. And we're going to set that to true so it actually returns us those 2 documents. And then we're going to create a prompt template for this chain. And the prompt template is going to be prompt template, new prompt template. And so the first part of this is going to be right here. Where is it? Right here. The template, which is just a string. Okay, so we'll pass in the string and we'll say assume you are an HR director, a human resources director. According to the resumes, answer this question. And we'll pass in an input variable of question. And the next thing that we need to pass is some input variables. And I need to specify, since we're using the object here, I need to specify that it's a template. And the input variables is going to be a string array, as you can see here. And the first one is going to be question, and give that a save. And then finally, we can use the format prompt to format the template with the input values that the user gives us, okay? So to make sure that we can pass question in, we just say const formatted prompt equals await prompt template dot format. And so dot format takes in the input value and it's going to return us that promise, which is a string. It resolves to a string, and that string is going to be the final prompt template with the question inputted in. Okay, so we'll create the prompt. So the prompt from the user is going to be injected into here. And that should be it. Well, let's just log the formatted prompt like that so we can see it. And let's test this out first to make sure our formatted prompt looks okay. Go back to our front end, give it a refresh, just get the question, go back to VS Code. And so, yeah, it looks like it's working properly. The formatted prompt is a string. It has that first part that we formatted, and then it's injecting our question in, which was who has experience with Python, and our question is getting put into there. So make sure that question matches question, and then you're passing question in with the stuff that you want to go in the question. So finally, now that we have the formatted prompt and the chain, we'll put those together and we'll await the chain.call and we'll pass in the query. And the query is just going to be this formatted prompt. And let's just console log that response. And then let's just make sure that we pass the response.text as the output. And then it's also going to take a source documents, which is the response.source documents. And this is just going to be an array of documents like this. Okay. And then this is just going to be a string. We'll give that a save. Give this a refresh. And check it out. All right, so it looks like it's working properly. It returns us that this backend developer has experience with Python. Let's just ask it again because it looks like our message got cut off. Who has experience with Python? Blah, blah, blah. and it looks like Joanna Smith has experience with Python. Let's go check out her resume and see if that's accurate or not. So we'll go to the data folder, which is here. Open this Finder and let's just verify this result. Okay, so the question was, one more time, who has experience in Python? And from our resume, it says that this candidate, Joanna Smith, has experience. I'm not seeing Python. Oh, yeah, there it is, Python. Okay, it looks like it is working properly, which is a good thing. And it looks like it gave us 2 documents. I think this one was me uploading it to the vector store earlier. As you can see, the metadata looks wrong, but this metadata looks correct. Okay. Awesome. So it looks like our resume to query with metadata is now working properly. Okay, so just to summarize everything that we did in this API route, first we grabbed the prompt from the user. Then we loaded the vector database up, and we did that by using Pinecone once again and passing our API key, environment, and the index. And then we were able to create a vector store from that Pinecone instance. Then we use the vector DB QA chain, and all that requires is the model and the vector store that it has to search through. And we set the k to 2, but you can set this number to 1 if you only want to return one source document. So make sure to set this to true if you want to return those source documents. And then in the prompt template here, we use the prompt template object to use a input string and pass a input variable of question into that prompt template. Then we use the .format method to properly input that question, which was the prompt from the user, and fill in that prompt template accordingly. Okay, in the last step, we just called the vector DB QA chain right here, and we were able to log the response back to the user as well as an array of source documents. Hello everyone, welcome to the